next section. In the previous section, we made sure to instantiate the world as the camera move. So if I was to press on play and then take my camera and move it around, we would have the scene generate itself over time. So like this. And that was fun and all, but now it is now time to have our player start running through this. However, there is one more prerequisite before we get to that point, and it's going to be the inputs. So this chapter or this section is all about inputs management with the new system, a new system that is brand new from 2020. Actually, it was there a little bit previously, but it now got officially released on 2020. So that is what we'll have a look at right now. Another reason I like this system so much more than the previous one is that it's much more optimal because it is event based. So we look for event within devices. These events are, for example, mouse movement. But when I'm not moving my mouse, it's not querying anything. It's not running any code. Only when I move my mouse will I get the mouse position. And it's all small tweaks like that that make it much more efficient to use. So let's go ahead and enable this input system. And to do so, we have to go get it as a package because Unity now works with small modules. If you like to have something, most of the time you have to install it. Like a big feature, you have to install it through the package, which is great because you don't have a lot of overhead if you're not using any. So let's go under Window, Package Manager, and we're going to be looking for the input system. Now I've already included mine, so I'll just remove and show you exactly how it's done. Basically, you have the package manager. Go ahead, wait until all the packages are loaded. You have to be connected to the internet, and then input system in the input field. So let's do it again together. Input here, make sure you are on all package. You find input system, and as you can see, it's version 1.0.0, released on April 29th of 2020. So you click install at the bottom right. This will take some time, and not only that, but at the end, it will ask you to restart Unity, and it's very, very important that you do so. So you will have to restart Unity once you're done. For me, it didn't ask because I was already put on the new input system because I previously had the package installed. So make sure you click it off and then reboot your project in Unity. You will be asked to enable the new input system. Again, it's very important you do so. By enabling the new input system, you're going to disable the old one. So we remove that overhead completely, and we're going to enable the new one. So it's going to be possible for us to use the new one. That's all we actually have to do within this one. Once the package is installed, I do suggest you create a new folder under script, call it inputs. And we're going to go ahead under the edit menu, project settings, you will find the input system package now here, and also the input manager. The input manager should have this error sign on it because this is disabled and we're no longer using the old inputs. Instead, you'll want to go under the input system package and let's create a setting asset. It has created a input system.input settings inside of my project folder. I'll go ahead and I'll drag and drop that in the new folder I just made. And these are basically configuration you can have. So this new input system, when is it going to update? In dynamic update, fixed update, or manually? Manually would mean that you have to call it through code in either a dynamic update or a fixed update. So I go for dynamic update, the regular one. Actually, all these settings right here, I'll leave them on default. Those are things such as tap radius, which means how many pixels in between two touch before they are considered just one. If you have a weird two-ended finger, that might be something you want to play around with. Double tap time, default tap time, all these things. I encourage you to just mouse over if you plan on using them. Dead zone is the most useful for me when I make joystick games. So when I make games with gamepad, other than that, the rest are really just other settings that you can have a look at. And the one important part down here is the supported devices. So which devices do you support? There is such things such as the mouse, the keyboard, the touchscreen. That's all things we will be using. So if you don't put anything in there, it's actually going to assume that every input received are supported. And I do encourage you to leave it empty at the moment until we're done with the actual game. So once we're done testing with everything, once we're done testing with Unity and with the browser and we're publishing our game, then maybe we can come here and say, hey, the only device we actually support is touchscreen and nothing else. But until then, since we need to test within the engine and also within the PC and maybe using a remote as well, then let's leave that open and hit save, close this off, and I will see you guys in the next one where we are going to start tackling a input action. This next part is about creating an input action. It will be an asset that helps you generate some code that will then decide which input are being looked for. To get started, we have to right-click on our folder, create, and at the bottom of the menu, you'll find input action is now available. I'll call this one runner input action. And we're going to open it by a double click. This window will now pop up, and this will be our friend for the rest of this video. I'll try to quickly go over it, but if we have a brief look at how the window is set up, you'll find here on the left-hand side action maps. These action maps will contain actions, and these actions will have properties. So it goes from left to right. So before I get into action map, however, let's have a look at the control scheme. At the top left over here, you will find control scheme. I do suggest you add one of them, and you can call it, for example, this one will be my computer control. So when I'm on my computer, I have access to these two devices, the keyboard and the mouse, not the virtual mouse, a real mouse. And I won't put that on required, however. So that would be the computer scheme. I will add another one for mobile. This one will only have touchscreen because that's all we have on mobile. I'm curious though if there's a gyroscope. Yeah, there's a gyroscope as well, but we won't be using it. I was just wondering if we had these. Okay, cool. So mobile will not be required either. Save, and now we have two scheme. So these scheme basically means, hey, you will have access to certain devices, and you can look at the list of devices. You had it pretty much over here. These are all the devices you can have and that are being supported right now. If you'd like, this input system is actually open source on GitHub, and you could add your own devices if you had your own type of. For example, I don't think HoloLens is being. Oh, never mind. It is being supported. Okay, never mind. But you could go ahead and code your own chip in there. So that being said, once we have these schemes, I will now suggest you go back on setting this on all control schemes because this act as a filter. We will now begin to create our action map. I would like you to see the action map as a set of inputs that you use within a certain context. For example, I could have a game that has a intro screen, and in the intro screen, you could like move stuff around in a certain way. You could move your mouse, it moves the background too. And then in the second screen, the gameplay, it's a completely new thing, and I can disregard everything inputs-wise. I can disregard everything related to the intro screen. Those are different action map being used at different times. I could even think that you could have a different action map for every single type of movement your player can have. Not that I recommend that, but for example, you could have a player that shapeshift into a bird, and it's a whole different action set in there. That being said, we only have one in our case. We only have the gameplay, and in fact, the intro screen is part of the gameplay as well. So we are going to create one action map called gameplay. And now you see, as soon as we created that, we now have access to a bunch of things on the right-hand side. And these are the actions. Now, these actions are not button themselves. So if I'm looking to track, for example, we'll do a couple of examples here. If I'm looking to track a mouse click, I'm not going to write left button in here. I'm actually going to say, hey, that's a tap, or that's a click. Tap, click. That will be the action. And then how can I produce a tap? I can produce it by clicking on my touchscreen, but I can also produce it by clicking on my left mouse button. So this is where the binding comes from, down here. And in my binding, I can now choose my binding and find, hey, that's a left button. So left button for mouse, that's good. I'll add a new one. So add binding. And this is a touchscreen This is a press. Actually, this is a tap. It's hard to find. So touch number 0/tap. Okay. So one action called tap can be executed in two different ways. So either through a left button with the mouse or a touch 0 tap. Okay, cool. Now this action will return a certain type of thing. So it will return a certain type of value. In this case, it is considered as a type of button, which means every time I press on the button or I click on my left mouse in this case, it is going to send the value over to whoever is ready to receive it. There's three different type of action you can have. Either button, which we just explained. So value is a little bit harder to explain. It actually looks for the previous value, and if it didn't change, then it's not going to send it over. So it's only looking for changes. And finally, pass-through is as soon as the event is called, the value is just passed through, and we don't even look if there was any changes. We don't do any of that. So that's really useful for things such as the mouse position. Value is really useful for things such as holding WASD on the keyboard for moving around, and button when the action is actually just a tap or click. Next up, we have the interaction. So the interaction is actually going to modify your input in such ways that it's only going to be called on one of these five, you could say, condition. So we can do press, and here you'll find it's only a press or it's a release only. So or press and release. So both can be true here. If we're doing a tap, we can tap, wait, release, and it could be considered as two buttons. So you know what? Let's add an interaction that does press only over here. And finally, the processor is actually the value you're sending over. Do you want to clamp it, normalize, invert, or put a dead zone on it? So it's like after the all action is done, you're trying to retrieve a value. Over here, it's a true or false because we're a type of button. We can't really clamp a true or false. We can't really normalize. We can invert it, however, but that's pretty much it. Okay, so that's a tap. A tap is fairly simple because it's a type of button and it's a true or false. Not too bad. Let's go into something a little bit more complex. So we're going to create a new action, and that action is actually going to be the cursor position. So let's do touch position. Since we're building something for mobile, I know we're integrating the computer control as well, but we'll just call it the names they need to be for mobile. This action will have a different type because here we're not trying to send a true or false. We're actually trying to send a vector 2. So we'll go here. We'll change our value to our types array to pass through, and the control type, that's sort of the return value, will now be under vector 2. And with that in mind, we can add. Actually, we don't need to add an interaction here. So I'm going to remove it. And this means that since we have a pass-through value, as soon as the binding changes or is actually being called by, for example, moving the mouse, then we will receive that value. These binding are quite simple. Here they are. They are called position, both for the touch screen and also the mouse. So I'll add this one here. I'll add a new binding again. This is position for the touch screen. Okay. So one thing I didn't mention for the tap is over here, the control scheme. I forgot to actually check this. For the left mouse button, we can only use it when we are on the computer scheme. And for the touch 0 tap, that's only on mobile. Same thing for down here. So position mouse is only on computer and position touchscreen is only on mobile. So what this is going to do is if you're booting the game on your mobile, it will not detect any mouse. It will not detect any of these required computer devices, and it will just not look for these. So it's a nice way to optimize a little bit more even. You can now find that you can modify controls. Sorry, you can filter this list based on your scheme, like so. And if you don't input anything, you'll see that they are being considered as global. So make sure you click on the proper one so they're not global, unless you want it, of course. One more thing that I want to do before we move on is I want to show you that all of these are actually blittable types. So all of these, if you click on the small 2 here, you'll see that they all have a string definition. So touchscreen is the device because it's in between these brackets. And then position would be the name of the control. Mouse position. Touchscreen, touch 0, then dash tap. Because the touchscreen can have multiple touches on it, and then they can all have their multiple tap. So here we're really looking for touch 0, and that might cause us a problem. For some reason, maybe you have one finger that lays on the screen and you still want to register a tap with the second one. What you can do, and I do recommend that you do, is go over here, remove the 0, and press the start button instead. That's the wild start to say any touch will do in this case. Then make sure to hit enter and you'll find that it has saved with the wild star. If, by the way, if you don't have anything that that registers, so for example, touch 1, 2, 3, 4, whatever, enter, it still looks good. So you gotta be really careful. But this one is from the documentation, so make sure you write it exactly like this: touch star tap. All right, so that's enough tests. Now let's go ahead and create the inputs we will need for pretty much the rest of our game. And those are the end drag and also the start drag. So I've created two of these, two new input scheme. And the action type will actually be, I believe those one are pass-through buttons. So both of them pass-through buttons. And the interaction within it is very important. That's what is going to change. So for the start drag, I am looking to press only, and on the end drag, it's going to be the release only. The inputs I'll be looking at, so the actual inputs are both the left button on the mouse, which is a computer only scheme, and the touchscreen press. So I'll add another binding, go here, touchscreen, touch star, and then press, which is a binding only for mobile. This one will not require any type of interaction. Down here, left button, so left button again. It's going to be the same thing basically. So left button, computer only. Add one more binding. This is touch press for mobile only. And just like so, we have created all the inputs we need for our game. Very, very small, but it's actually going to be very efficient. So let's go ahead and click Save Asset. You also had the option to auto-save every time you had a modification, but I don't recommend you do that because it's quite laggy when you work with the inputs. So just make sure you save at the end. Final thing we'll need to do for this one is click on the runner input action. Make sure we generate a C# class. The default setting is actually the folder I'm in, so I'm going to hit apply. And it now has created what we'll need to use for our script. So it created a C# script that is quite long. It has been generated. And it's a big JSON file that, as you can see, has all the control we actually put in there. So my left mouse button is here, and you could go ahead and read that. Quite a lot of code, but everything is there, and that's what we needed to do today. And I'm quite happy we didn't have to write all of this. Instead, we had something that helped us create the input action. So that being said, in the next one, we will start looking at importing them within our own script and then using those globally within the application. We are now going to create our own version of the input manager. This will sit in the middle of all the calls we do to input and the runner input action we've created in the previous video. So I'm going to start right away by creating a new C# script called the input manager, and I'll open it as we usually do. I'm going to clean up everything at the top here. This is going to inherit from model behavior. Yep, so I'll put back in the engine. I'll clean up everything else and let's get started. So we are going to create something that is a static instance. Now, we don't do that quite often, and when we do, we got to make sure that it's an object that will only be at a single place in the game. So it's not going to be a script that is spawned twice, you could say. So this input manager will be on an object, and that object will persist throughout the whole game. It's going to be a static instance. You could see it as some sort of singleton, but it's not going to be a full-fledged singleton in this case. So to make sure that there is only one of these in the scene. I'll start with a private static input manager instance like so. And then we'll create the public instance over here. So public static input manager instance, and we'll only do a get here. It's very important we only do a get, else we might have other script that will overwrite this by accident. That's not what we want. So the only person right now who can set instance would be ourself, our private self. So anything that happens within this script. And in fact, let's go ahead and do that right now. We'll do it in a private void awake. We'll say instance is equal to this, and we'll say don't destroy on load. By doing this, oh, actually, let's specify what we don't destroy, this whole game object. By doing this, whenever this object will be spawned anywhere in the map, it is going to set itself as the static instance. And then after that, from other script, we can call instance with a capital, but we can't say that instance with a capital is equal to something else. So we won't be overriding it. There is other implementation that are much better of the singleton, but I don't like showing them here because it might confuse people a little bit. And that is how we're going to get our static instance. Now, do know there is a much cleaner way of doing this, you could say. For example, when I'm on my own, I usually use the mono singleton. It's a script that is wide known. And you just have that in your project somewhere, and then you can call mono singleton here and do input manager. And just like that, you'll have an instance that is inherited from here. But I am not going to do this in a course for the sole purpose that I want you to be exposed to this. I don't want to add a layer of complexity hidden behind a templatable class that you inherit. So instead, let's keep it this way. It's a little bit less clean. And if you're interested, I do encourage that you just grab the script, put it somewhere in your project, and do as I just showed you. Only if you're interested in having this be a little bit more complex, but having that complexity makes it so you lose these 3 lines here and even this one. Okay, enough talk. The next thing we'll need is the action scheme. So the action schemes. I'll put an S, but I'm not going to have more than one. Actually, we only have the runner input action. This is actually created from action scheme. This is created from the script we've generated in the previous episode. So this class is generated, as you can see, if I press F12, generated automatically from this asset. All right. So here we don't actually need to assign it to anything. So I'm not going to like make that public or make that serializable and drag and drop the thing. Instead, what will happen is we are going to create one with the new call. So we're going to construct one. The way we'll do it, and I want to do it in a separate function called setup controls. And we'll call that from the awake. So basically, this is a extension of the awake, but I'm just splitting them apart because this one is only related to the control. I'll do action scheme is going to be equal to a new runner input action. And this will create our object over here. Now the constructor is over here in the generated. So what happened when we create a new runner input action? It basically creates this asset from the JSON file. So it's like, it seems to be hard coded. You also get all of these, but that is how the system works. So it sets the JSON file based on what we've edited in the previous video. Okay, now on top of that, what actually happens now that we have the action scheme is that there is different action events being out there, part of this object now. And we are going to bind ourselves to them. So we're going to register different actions to whatever function we have. Let's have a look. So action scheme dot, and then you'll find dot gameplay. So this is the action scheme. And then within that, we'll find all the action we defined, such as tap, I believe was position, touch position, and drag. So start and end drag. So I'm going to go ahead and actually register all of them. Even though we're not going to be using tap, I'll register it like this. So when tap is, now you'll see there's one here called canceled. We're looking for events, by the way, so you can just click here and it's going to sort them. There's only 3 different events: started, performed, or cancel. So in our case, when start is performed, we can then add a context
on tap is going to be the name of my function, like so. Now this looks a little bit odd, but bear with me and double click on untap. Control dot will help you generate a method. So private void on tap, like so. Oh, and we should actually keep our context. So let's actually remove that. Let me input context here, then generate my function. Yep, now we get the input action callback context. I believe we can remove this, maybe. No, we can't. Okay, let's keep it. All right, so this is for the tap action. Next up, we're going to use another one. So action scheme, gameplay again. We'll do touch position. When this one is performed, we're going to add the following function to it. On position, then we'll send the context. In this case, context will be useful. Create a new function. Yep, we've got this one. Next up, we've got the drags. So start drag over here, dot perform plus equal context on start drag. Send in the context once more. I'll copy that and I'll do end drag here. Make sure I generate both of these functions. And there we go. So we just created the for recipient of these events. So when these events are being called, then these function will be triggered. All right, awesome. So we've got all of these now. It's actually going to be time for us to define the field we'll be pulling from other script. So I'll just collapse these together. And at the very top here, I'll create myself a new region, and that's going to be for public properties. These are properties that will be get only, so we won't be able to set them, and they will actually point toward during this frame. Are we tapping? Are we swiping left, right, down, up? And where is our mouse position? So for example, I'll do a public vector2. Let's call it touch position. And here we'll do get, and we'll return a private value. So here that will be touch position, not in capitals. And actually, that makes me think that we'll also need the privates. So I'll copy that over. The private value will be right here. So these will be private. Vector2 will be touch position like so. And we don't need the rest. Now, the way this is set up, if we need to get the touch position from anywhere in our code, we can go like this. We can say input manager dot instance touch position, and we'll have it right here. That's going to be the vector2. Now, of course, we don't need to do that here because we're already in instance. Like we already have all of that, and we actually can call the private value if we wish. So we don't need to do that here. But in the future, from other script, we'll need to go through this very specific getter, which is good now because you get to have an abstract layer in case you want to add something on top of that. I'm not thinking of anything right now, but for example, let me do something else that might be a little bit more evident to you. So we could do, and I invite you to do the same because that's going to be useful, private boolean tap to know whether or not we're tapping during this frame. So public boolean tap get return the private value we just created. So by doing this here, yep, we have the private boolean tap, which will contain the right value. And we have this one, which returns the private value. Okay, that's totally fine. But when we call it from outside, so when we call it from another script, for example, from junk.cs, and we want to do something like input manager, instance tap, like so, we don't have access to tap with a small capital, well, without a capital, but we have access to the property. And what this gives us is the opportunity for, at one point, if you wish so, you can actually count the amount of tap there is. So you could go here and say, hey, private in tap count is going to be equal to 0 at first. And then every time that somebody calls tap, you could go ahead and say, well, before you return tap, let me just make sure that I do tap count plus plus first. I just sneak that line of code in there in my getter. Not that I will be using the tap count, but you get the point. Plus, it's also a good practice because we are now hiding the one that contains the real value. And when we're exposing this, we're only exposing the get part. So somebody else, so another script, for example, will be looking for tap. He won't be able to say tap is equal to something. The only person who can say tap is equal to something is actually no one. Nobody can actually set this value. We only return the private value. And the private value, the only person who can set it, is going to be us. So this script, this private script here. So this is the idea behind making these get only and also having the privates. It's just good practice. And it also shields you from other people overwriting your code. Next up, I'll be creating a new vector too called start drag. But I don't believe I'll be using this outside of this script, so I won't be exposing it, which means I won't be creating a public property for this one. And finally, there is 4 different values that I'll be using: swipe left, private bool, swipe right, private bool, swipe up, and of course, you got it, swipe down. These will all be private, but I'll also be exposing them at the top here. So all of these can now become public. If you're curious, holding Alt on my keyboard makes me multi-select in Visual Studio, so that's always fun. And then I'll change these for capital S, and of course, start writing the return value, which is going to be the same thing, but of course, with the smaller letter. Oh, here's a small typo. There we go. One last thing we have to do regarding this specific input system is to enable the action set. So over here, you'll see when we do a setup control, we have the action scheme and all of that, but we need to do something else in between that. We need to activate looking for these input. And also, if we decide at one point to disable the input manager, we also need to disable looking for these input, just so we can save a little bit of bandwidth. So at the very bottom here, I'll create a public void on enable and also public void on disable. These are callback from Unity since we're in mono behavior and will be called automatically if we enable the object. So if the game object is not active and we turn it on, then it's going to call on enable. And if we turn it off, of course, it will call on disable. Now my action scheme can be enabled as well, like so, and it can be disabled. I invite you to do so you can save a little bit of bandwidth when we do turn them on or off. Okay, and just like this, we will wrap up this episode. In the next one, we will be looking at these 4 functions here. We'll be looking at implementing these 4 and then maybe testing in a future video. So we'll see then. Cheers. In the previous video, we started implementing the input manager. In this one, we will implement these 4 functions right here. We'll go from the easiest one to the hardest. They're pretty much all easy, but I'd like to isolate this video just so we have the swipe logic being contained in there in this single video. So let's go ahead and start looking at how we're going to parse all of this logic. Now, what we'll be setting is actually these private values. If you guys remember, we've created all of these private values so our public property could contain them and other script could call them. So what is important for us to set are all of these. So we're going to find a way to set all of these in these 4 functions here. But we are missing one single function, and that single function is called the reset. So under the awake, I'll do something else. I'll first create a private void late update, and then I'll create a private void reset inputs. I like to wrap functions in other functions like so. In my late update, I will be calling reset inputs. Technically, that's the only thing that will go within the late update as of right now, but if you wish, you could put something else in there. I just like to isolate logic so we understand what this function does properly. And in this reset input, here is what is going to happen. First up, tap is going to be equal to false. Also, swipe left is going to be equal to false. And swipe right. And swipe up, swipe down, and so on. So you get the point. We're just going to reset all the input to be put on false. If you want to be a little bit fancy, you can go ahead and do something like so. Swipe right, which swipe right is going to be equal to swipe up, and then swipe up is going to be equal to swipe down, and swipe down will be equal to false. So in a one-liner, one weird, ugly one-liner, we are able to reset all the Boolean values. The only thing we did not reset in here is the touch position and also the start drag, which we will do within these four. Now, just to make sure that you're on track with what we're currently doing here, every single frame, we are going to be looking for events. These events will be parsed in a dynamic update, as we know, because that has been set within the input settings. In a dynamic update, not a late update, dynamic update, we will be setting these. So if we're tapping, tap is going to be equal to true. And then at the end, not really the end, but like at the later time during the frame, we're going to be putting it back to false. So timing wise, we will have a small problem in which we'll address very quickly after this. So let's go ahead, now that we have our recent input, let's go ahead and start coding these. We'll go from the easiest one to the hardest. First up, on tap. We actually don't need the context in this one. We can just say tap is equal to true. And that is it. We actually don't need to do anything else. The second easiest one is on position. We have to get the value from context and put it under position. So touch position is going to be equal to the context. And here we will be reading the value type of vector2. And like so, we will be getting the position of our cursor, of our mouse, of our touch screen, where our finger is basically. Okay, next up is the start drag. So for start drag is going to be equal to mouse position. Oh, not mouse position debug, sorry, touch position. Here we go. And make sure you put the one that doesn't have a capital. It doesn't matter if you do, but you are saving one cycle, one CPU cycle, because you're not calling it from here. Then here goes into, oh, I just did a huge mistake. Okay, there we go. Touch position with a small t. That could have created an infinite loop, so I'm glad I found it here before I pressed and play. But yeah, if you actually call this with the capital T, it goes inside of here, then inside of there. We don't need to do that because we are in the private script. We are in the private parts of the script, you could say. Okay. Next up, we have on and drag. And this is actually where all the logic really happens. This is where we do our swipe logic. And this one will be complicated. We will start by getting a delta position on where our cursor is based on where we started our drag. So we'll do a vector2 delta, and we'll do touch position minus the start drag. That will give us where our cursor has traveled ever since we pressed for the first time. Well, not the first time, but last time we pressed. Then what we'll do is we'll get the square distance of that delta, so squared magnitude. I'm doing square because I don't want to do magnitude. I don't want to have to do the square root because it's an expensive operation. So instead, we'll just do, we will use a square distance instead. Now let's go ahead and do if the square distance is bigger than a certain amount. So that's going to be how far do you have to swipe before it is actually being considered a swipe. This one we don't have it anywhere, I believe. I do have in my notes here that I've been using a hard value of 50. So 50, that's not 50 pixels. That's actually, you have to do the square root of that to find how many real pixel this is. But you know what? Let's scroll up at the top here and create a serializable field here. So configuration, serialize field, private float square swipe dead zone. And I'll put that on 50 here. We can now replace this value with the following and keep on coding. So this if right here gives us two different routes. Either this is a confirmed swipe because we went far enough with our finger that we are now confirmed as a swipe, or we've just released before we had the time to do a swipe. And if that's the case, then I'd like to do the following. I'd like to say start drag is going to be equal back to 0. So we reset this if we're done. So even if we have a swipe, once we're done, we reset that back to 0. Okay, now assuming we have a swipe, we have to know in which direction the swipe is. So let's go ahead and do a little bit of maths. We'll start with x, matf.absolute, delta.x, and we'll do the same thing for y. This will give us the absolute value. So if it was minus 5, it's now 5. If it was minus 3.25, then it's now 3.25. This just removes all the negative value and turn them into positive. Knowing that, we can now check if x was bigger than y, it means we're either going left or right. Now, if that's not the case, it would mean that we have to go either up or down. So this is left or right. And here, this is up or down. And I keep making typos. Okay. If we know that our swipe distance in x is bigger than y, it means we're going left or right. At this point, the only thing that will tell us if it was left or right will be our value, but without the absolute on it. So we got to make sure we are not doing an absolute on this call. So if this delta.x is positive, it will mean that we're going right. And if it's not, it means we're going left. So if delta.x is bigger than 0, then swipe right will be equal to true, else swipe left is going to be equal to true. We'll do the same logic down here, but with delta y, of course. If delta y is positive, swipe up, else swipe down. And do remember, we don't need to set them on false because the reset input on every single late update will do it for us. And that is it, actually. We don't need to do anything else for the drag logic. What we will be doing next is we're going to address something that might not be a problem, but might also be a problem depending on how lucky you are. And that's the execution in which the script are being rendered. So if I was to do a timeline, we have at the beginning here, we have the awake, wait. So if I was to do a quick timeline over here, we have the dynamic update, which it has our input manager that process. Okay, cool. I can't write the inputs. So the swipes. And then we have the input manager resets these inputs. The problem we can run into at this point is that now the problem that arises here is depending on the order in which the scripts are being processed. If this is my player motor uses these inputs to move, then we're completely fine here because the input manager will set the flags to say, hey, there was a swipe. And then the player motor will say, okay, there was a swipe, I can now move. However, if you're unlucky and it looks like this instead, at the beginning of the frame, the player will say, okay, do we have any inputs? No, they're always on false. Then the input manager will set them, nobody will use them, and then he will reset. So next frame, even if we had a swipe, the player motor will not know. So it's very important that we go in our setting and we actually change when the input manager is being processed. It should be processed at the very, very beginning of the frame. Our input should be the first thing that comes in play when we're running the whole dynamic update loop. So to do so, and you know what, I'll actually leave this example in here. To do so, we are going to go under Edit, Project, Settings, and under the script execution order, I'll add something, and that something will be, we'll have to find here the input manager, like right here. And I'll make sure to drag and drop this right before, or right after, sorry, the Unity Engine input system player input. I'll put it right in here. So everything that is after that would be considered something that is positive, for example, our player motor, and will be parsed properly. So knowing this, I'll hit apply, and our input should now work. All right. Now, in terms of the inputs, if they work or not, we will be testing them in the optional. There's an optional video just beneath this one in this section. If you'd like to skip it, we'll test it in the player motor as well. So once we start creating the control for movement for player, we will apply them here, of course. So we'll be having the chance to test them there. But in case you want to go a little bit deeper in this section and just create a script that will test these, then feel free to do so. It's the next one. Otherwise, I'll see you